it is time for 6.3. So this is logarithms. This problem is super easy. All you have to do is plug in the ln of 25.9 in your calculator or log of 3 over 7. Done. Sick. Is that what we said? I'm not sick. You're sick. Okay. Here we need to solve this. So we ln both sides. Drop the x minus 8. So x minus 8 times the ln of 12 is equal to the ln of 15. You could use log. I prefer ln because I'm lazy. So we divide by the ln of 12, and then we add 8. So when you plug it in your calculator, make sure the parentheses look like that. Easy enough? All right. Log base 9 of 1 over 7. Does our calculator have ninth gear? No. What gears does it have? 10 or E. So either you do the ln of 1 over 7 divided by the ln of 9, or the other option would be log of 1 over 7, that's a 4, over the log of 9. And that is called the change of base formula. If you don't have that button on your calculator, then just convert it to a button that you do have. All right. Here we ln both sides, and this is a little bit tricky. So we drop the negative 9x ln of 15, and that's equal to x, wow, that was bad, x minus 10 ln of 14. So these are just numbers. And I would use quite a few decimals. So the ln of 15 is 2 point, well, actually, here's what I would do. I would divide by the ln of 14, divide by the ln of 14, and then you're only dealing with one nasty decimal. So the ln of 15 divided by the ln of 14 is negative 9x times 1.02615. And notice how it says do not round any intermediate computations. You need a lot of decimals here in order for it to work. In fact, with logarithms, you have to be really specific. So 0, 2, 6, 1. Oh, I even wrote it down wrong. 1, 4, 2, 9, 9, 8. And that is equal to x minus 10. So we're going to subtract x, and I get negative 10x times all of this stuff equals negative 10. Oh, how nice is that? So we divide by negative 10, and I get x times 1.026142998 is equal to 1. So I'm just going to divide this by my answer. So 1 divided by answer, and I get 0.9745. And so it's going to be 0.975. Does that make sense? Okay. All right, same idea here. 7x ln of 17 is equal to x plus 2 ln of 5. And I would divide again. That way you only have one bad number. So the ln of 17 divided by the ln of 5 is going to be 7x times 1.76, and it has a lot more numbers. And that is equal to x plus 2. So we subtract x, and I get 6x times 1.76 equals 2. So I'm going to divide that by 6. Whatever answer I get there, I'm going to divide that by 1.76, and I'll just use the answer button. So 2 divided by 6 divided by, I can't, this calculator is a little weird. So I get 0.189, and that's my answer. Oh, no, write it as an exact answer. Okay, well, back up, guys. I apologize. I got to read the instructions. So 7x ln of 17 equals x plus 2 ln of 5. So I'm going to distribute this. 7x ln 17 equals x ln 5 plus 2 ln 5. Okay, does everybody see what I did? Now I need to move the x's to one side and everything else to the other side. So I'm going to subtract this over. So I get 7x ln of 17 minus x ln 5 is equal to 2 ln 5. Now I pull the x out. So this and this come out. X times 7 ln 17 minus the ln of 5 is equal to 2 ln of 5. Now what? Divide. So I'm going to divide by all this. X is equal to 2 ln 5 over 7 ln 17 minus the ln of 5. And you would need parentheses there. Oop, not there. And here, and here, and here. Where? No, because it's kind of like saying if we had 3 times 2 minus 7 equals 2 plus 7. So we have a negative ln 5 here, and we have an ln 5 here. Do these cancel? Not really, because there are actually 3 of them. So there is a way to simplify this. So this right here can be written as the ln 17 to the 7th over the ln of 5. So if you want to, you can use the product and quotient rules, in which case we would have x times the ln of 17 over 7 divided by the ln of 5. And that's equal to 2 ln 5. And then when we divide, we just multiply by the reciprocal. So that's times the ln of 5 over the ln of 17 over 7. And so that looks like it simplifies, but the product rule does not allow for simplification of the multiplication of logarithms. So that's sort of 2 times the ln of 5 squared, but the squared is not on the 5, it's on the ln. So that might be considered a more simple version, but anyway, they should both work. Alex has a pretty good computer algebra system, so as long as you put in a version that has the same equivalent decimal value, it's going to mark it correct. All right, that's it. Get to work.